Next question is, a company has an application that runs on Amazon EC2 instances and uses an Amazon Aurora database. The EC2 instances connect to the database by using usernames and passwords that are stored locally in a file. The company wants to minimize the operational overhead of credential management. What should a solution architect do to accomplish this goal? Option A. Use AWS Secrets Manager. Turn on automatic rotation. Option B. Use AWS System Manager. Parameter store turn on automatic rotation. Option C. Create an Amazon S3 bucket to store objects that are encrypted with an AWS Key Management Service, AWS KMS encryption key. Migrate the credential file to the S3 bucket. Point the application to the S3 bucket. Option D. Create an encrypted Amazon Elastic Block Store Amazon EBS volume for each EC2 instance. Attach the new EBS volume to each EC2 instance. Migrate the credential file to the new EBS volume. Point the application to the new EBS volume. Correct answer is option A. Use AWS Secrets Manager. Turn on automatic rotation. Next question is, a global company hosts its web application on Amazon EC2 instances behind an application load balancer. ALB, the web application, has static data and dynamic data. The company stores its static data in an Amazon S3 bucket. The company wants to improve performance and reduce latency for the static data and dynamic data. The company is using its own domain name registered with Amazon Route 53. What should a solutions architect do to meet these requirements? Option A. Create an Amazon CloudFront distribution that has the S3 bucket and the ALB as origins. Configure Route 53 to route traffic to the CloudFront distribution. Option B. Create an Amazon CloudFront distribution that has the ALB as an origin. Create an AWS Global Accelerator standard accelerator that has the S3 bucket as an endpoint. Configure Route 53 to route traffic to the CloudFront distribution. Option C. Create an Amazon CloudFront distribution that has the S3 bucket as an origin. Create an AWS Global Accelerator standard accelerator that has the ALB and the CloudFront distribution as the endpoints. Create a custom domain name that points to the accelerator DNS name. Use the custom domain name as the endpoint for the web application. Option D. Create an Amazon CloudFront distribution that has the ALB as an origin. Create an AWS Global Accelerator standard accelerator that has the S3 bucket as an endpoint. Create two domain names. Point one domain name to the CloudFront DNS name for the dynamic content. Point the other domain name to the accelerator DNS name for static content. Use the domain names as endpoints for the web application. Correct answer is option A. Create an Amazon CloudFront distribution that has the S3 bucket and the ALB as origins. Configure Route 53 to route traffic to the CloudFront distribution. Next question is, a company performs monthly maintenance on its AWS infrastructure. During these maintenance activities, the company needs to rotate the credentials for its Amazon RDS for MySQL database across multiple AWS regions. Which solution will meet these requirements with the least operational overhead? Option A. Store the credentials as secrets in AWS Secrets Manager. Use multi-region secret replication for the required regions. Configure Secrets Manager to rotate the secrets on a schedule. Option B. Store the credentials as secret in AWS System Manager by creating a secure string parameter. Use multi-region secret replication for the required regions. Configure Systems Manager to rotate the secrets on a schedule. Option C. Store the credentials in an Amazon S3 bucket that has server-side encryption SSE enabled. Use Amazon Event Breeze Amazon CloudWatch events to invoke an AWS Lambda function to rotate the credentials. Option D. Encrypt the credentials as secret by using AWS Key Management Service AWS KMS multi-region customer managed keys. Store the secrets in an Amazon DynamoDB global table. Use an AWS Lambda function to retrieve the secrets from DynamoDB. Use the RDS API to rotate the secrets. Correct answer is option A. Store the credentials as secrets in AWS Secret Manager. Use multi-region secret replication for the required regions. Configure Secrets Manager to rotate the secrets on a schedule. Next question is, a company runs an e-commerce application on Amazon EC2 instances behind an application load balancer. The instances run in an Amazon EC2 auto-scaling group across multiple availability zones. The auto-scaling group scales based on CPU utilization metrics. The e-commerce application stores the transaction data in MySQL 8.0 database that is hosted on a large EC2 instance. The database's performance degrades quickly as application load increases. The application handles more read requests than write transactions. The company wants a solution that will automatically scale the database to meet the demand of unpredictable read workloads while maintaining high availability. Which solution will meet these requirements? Option A. Use Amazon Redshift with a single node for reader and compute functionality. Option B. Use Amazon RDS with a single AZ deployment. Configure Amazon RDS to add reader instances in a different availability zone. Option C. Use Amazon Aurora with a multi-AZ deployment. Configure Aurora auto-scaling with Aurora replicas. Option D. Use Amazon Elasticache for memcached with EC2 spot instances. Correct answer is option C. Use Amazon Aurora with a multi-AZ deployment. Configure Aurora auto-scaling with Aurora replicas.